Hi, welcome back. We're going to be looking at Chapter 8 for the second week of Fall CS 170. This is going to cover representation digitally for video, uh, pictures, and sound. I think for this clip, we're probably going to cover the picture side of things, and then we'll pick up the sound in another clip. So here we go. Um, So this left side here, where it says digitizing color, we'll be taking a look at that for this lecture, and then we'll pick up the right side in a subsequent lecture. Okay, so you guys have probably seen many forms of digital media, anything from pictures to sound, videos. Uh, so we'll start off with the basics here. So from a picture standpoint, um, if you look at, let's say, your monitor, um, everything that you see on there in terms of images will be represented by small points, which are called pixels. And the makeup of each pixel is three colored lights, red, green, and blue. And we'll get into like how you blend those colors to create like a whole spectrum of different colors. But if you were to set all of those values to be 0, which is the absence of light, you get a black dot in that pixel. And then if you hit the maximum for each of those points, red, green, and blue, you would get white. Okay, so it's a little bit different than probably what you think about in mixing colors in art class, where you mix all the colors, you end up with black. Um, so this is how it works from a digital standpoint. Okay, um, we use a byte to denote the intensity of the light. Um, and you remember how many bits are going into a byte would be 8 bits going into a byte. Okay, so the color for each pixel is going to require 3 bytes, which is 1 byte for each color. Okay, so if you add all of that up, 3 times 8 bits is 24 bits. Okay, so that's how you end up with 24 bits, which is 2 to the 24th, and you basically get over 16 million possible colors, which would be just going through all of the possible variations for those 24 bits. Okay, so probably for subsequent quizzes or tests, there'll be some different questions that we'll be asking. One of them would be to, let's say, look at a photo. And in this case, the example is 479 pixels by 332 pixels. Right, so let's say you have this picture with this hammerhead shark here. Let's say it's 479 pixels across, 332 pixels up and down. Multiply the two together, it's basically the area. You get over 159,000 pixels. Okay, and then each pixel has a red, green, and blue component, which is represented by 3 numbers. Right, so let's say the 51 is the red, 153 is the green, and 255 is the blue. 255 being the max for the blue, let's say. Okay, so if you count each pixel, multiply by 24 bits, which is the 8 bits by 3 colors we mentioned before, you'll get 24 times the 159,000, and you get over 3 million bits. Okay, so these are things that you probably would just have some simple question along these lines, where you get a picture, you multiply out the pixels, and you multiply that by the number of bits represented for each pixel to get the total number here. Okay, um, here. So again, to reiterate, you have black as the absence of light, which means all of these are 0. Okay, so 0 for the red, 0 for the green, and 0 for the blue. This is the binary representation. The decimal representation is also 0, 0, 0, and the hex representation is 0, 0, 0. Okay, them all being 0, I don't know how interesting that might be. Maybe you can see it a little bit better with this when you look at the white. White is the full intensity. It means all of the colors are maxed out. Red, green, and blue are maxed out. So for the binary, you can see it's all ones all the way across for everything. Okay. For decimal, there's a number you might recognize more. It's 255 for each one. Okay, and then hex is F's all the way across. Okay, so all it means is that whichever representation, whether it's binary, decimal, or hex, you're just going to max out all three colors to get the white color. Okay, so a question here would be, what do you get if you do a RGB with this? So 0 for red, 255 for the green, and 0 for blue. Okay, as you can imagine, you're probably going to be looking at a green color, right? So there's no red, there's no blue, and you're maxed out on the green. You should end up with a green color for that pixel coming out to you. Okay, and there's going to be different variations of this. We'll talk about like shifting colors and making one color stronger than the other, things like that to play around with how to represent each pixel color. Okay, so now this is talking about when you have a picture that's been transformed into a digital representation, you can do various types of manipulation, right? And you're obviously not going to go down to each and every single pixel and manipulate it one by one at each pixel level. You'll probably run some mathematical formula to play around to do some special effects, right? So you'll look for certain values and maybe you'll shift them in some way, right? It could be like, a plus whatever, plus 20, plus 100 across the board for each pixel for each color, or you might be looking for, very dark type of areas and do certain things, and look for lighter type of areas to do something different. But you have an example, let's say the red eye removal. Okay, so you can imagine red eye removal, you'd probably be looking for pixels that are tending more towards the strong intensity for red. Okay, and then you'll change it to something else. Maybe you do like, a red, everything that's very strong on red, you would do a minus whatever, minus 100 on it or something to reduce the red, the strength of the red. So you can apply different types of algorithms once you have an image digitized. Okay, you can imagine other different types of things in photo corrections. You can imagine doing things sort of like interpolation and whatnot to fill in gaps in the image. Okay, so some simple type of things you can look at, which this is what we'll be talking about for the purpose of our class, is looking at the brightness and the contrast. Okay, so the brightness is talking about how close to white the pixels are. Okay, as you remember, we were talking about you increase the intensity across the board all the way up to the max, you get completely white. You're probably not going to want to make it completely white because all of a sudden you just have a white picture, right? So there'll be some variation of that. So maybe you decide you want to, do a plus, whatever, plus 50 or something to kind of lighten it up a little bit, but still retain some of the picture. And the contrast is looking at the difference between the lightest and the darkest portions of the image. So how much of a delta there is between the two to basically contrast, right? Make things stand out a little bit. Okay, so let's take a look here. Okay, So this kind of continues on with what I was discussing before. So this is a black and white picture of Abraham Lincoln. Okay, so you want all the pixels to be white, so you keep you want to make it more intense, right? So you want to make it more white, more intense, and you want to keep the relative relationships to each other. Okay, so in this case, we're saying add 14 to each pixel, right? So each pixel for the red, green, and blue, you're going to add 14. Okay, so in this case, you start off with 195, 195, 195. You add 14 to it, and it becomes 209 across the board. Okay, um, and in this case here, like the darker ones, um, you're going to add all the way across, and you end up with 36, 37, 38, and you get something like that. Okay, um, and so you'll end up with something like this. So basically, all across the board, whether it's like the light color pixels, which are these guys up here, or the darker ones, which are these guys down here, you added 14 to each pixel. So it pretty much went from the top image to the below image here. Okay. Now you go to the contrast. Um, so instead of like looking at things the same throughout everything, um, you're gonna try to add an amount, a smaller amount to the darker pixel and a larger amount to the light pixels. Okay, so let me come back to the prior slide. So this one is kind of like a more simple type of enhancement to the picture, and that's why you get this type of result, which not really that ideal. Um, and so that's why you get this idea here to vary how much you're going to add to the pixel. Um, so you're going to, like I said, you're going to add the smaller amount to the dark pixels and a larger amount to the light pixels, and you can get the result here on the right hand side here. Okay, so a little bit better, makes things kind of more crisp, you can say, right, in terms of the colors. Okay, so things maybe stand out a little bit better. You don't get like, I guess they might refer to it as washing out the image. Okay, so here on the contrast, you're looking at the darkest pixel is this 38, which is the lowest number. And then the lightest pixel, which would be the biggest number, is 239. Okay, um, and so you can see here for the lighter pixel, you went from these numbers here up to this number here. Okay, um, and yet for the darker pixel, which are these smaller numbers here, we only went up a small amount. So you can see 57 went up to 59, 72 went up to 75. Okay, and hence you get something like this. Okay, so it kind of increase the difference between the lightest and the darkest. Hence why you refer to contrast in this way. Okay. So now you're looking at trying to add color to this. So this is where you look at the different values here. You can see like what it's pointing to here in terms of shadows, mid-range, and highlights. So these are like the white colors here. This is something in between, and then these are the darkest colors. And then based on those groupings, right, so you can, there's a number of different ways you can group this. They're just kind of doing a simple grouping here. Then you say, for each of those type of groupings, you're going to change the red, green, and blue by this amount to try to add some color to it. Okay? And by doing that, you end up with something like this. Okay, so let me go back to here. All right, so by adding color, what you're doing is, adding these type of values or subtracting, in this case for the blues, to try to add some color based on the groupings. Okay, so like I said, in this case, they chose to group the pixel types by the highlights, mid-range, and shadows, which is like this. And then they just added the red and the greens here and took out some of the blues. And you end up with something like that. Okay, so the main takeaway when you're looking at images is one, this idea of the pixels and being able to represent the pixels with the red, green, and blue, right? And if you max out on all of the pixels, you're going to end up with a white color. And if you take away, make it 0 for all of the three values, red, green, and blue, you end up with black. Okay, and then playing with the in between gets you some shades of gray or colors in between. Okay, so that's part of the main takeaway. Be able to take a picture, calculate how many pixels there are, and look at how you represent that. In this case, it's over 3 million bits. Okay, and then within that, the fact that you have red, green, and blue, how you want to either make it more dark, make it more white, so how to make things brighter, and then how to play around with the contrast, which is the difference between the blackest or the lowest color pixels versus the brightest or the whitest pixels, right? So those are the main ideas you want to take away for image processing or image representation digitally. Okay. So the next video clip is going to cover sound, digitizing sound. So I'm going to end this clip for now, and